Okay, category 3. This is going to be the most heavily tested category. So 12 out of your 60 questions will come out of category 3. On the bright side, we've covered a lot in category 3 in class. It's kind of why we've been so heavy on that. So this is all the properties of quadratic functions. So I'm going to start with supporting standards. First of all, you have to be able to determine a quadratic function from its roots, real or complex, or a graph. So first things you need to remember are that when you talk about solutions, we're talking about the zeros right here, the roots. So we can find that by finding our x-intercepts. If it only touches the x-axis, remember we write that root down twice because it's a double root. And if it doesn't touch the x-axis at all, then they are complex or imaginary roots. So we'll have to do something different to find those. What they're saying specifically here, though, is that you have to be able to come up with the function itself, starting with its roots. So let's say I was given the roots 3 and -5, meaning that when I graphed this, the x-intercepts were at 3 and -5. So if its roots are 3 and -5, then its factors, then its factors are x minus 3 and x plus 5. Okay, so then I can FOIL this out and I can come up with the original quadratic function. So first times first is going to give me x squared. X times 5 gives me a positive 5x. Negative 3 times x. And then finally negative 3 times 5. And I can combine like terms, so x squared plus 2x minus 15 should be my original quadratic function. And I can check that by graphing this and checking the x-intercepts, and they should be at 3 and -5 if I was correct here. I can do the same thing with complex or imaginary roots, but with this you have to remember that when you have complex roots, you have both a positive and a negative version of the same thing. So if I have x equals 7i as one root, then I have x equals negative 7i as my other root, because they're going to be conjugates. So my factors would then be x plus 7i and x minus 7i. And again, we're just going to distribute through here, so I have x squared minus 7i x plus 7i x, isn't that nice, minus 49i squared. Okay, so here in the center, these are going to zero each other out, negative 7ix and a positive 7ix. And I'm left with minus 49i squared. So here's another thing to remember. I squared equals -1. So that is actually a negative 49 times a -1, which makes this a positive 49. And so then that should be my original quadratic function. So that's what they want you to be able to do in that standard. Second supporting standard, analyze and interpret solutions of quadratic equations using discriminants, and then solve using the quadratic formula. Okay, quadratic formula will be provided on your formula chart. They will not tell you specifically what the discriminant is. It's also given to you, though. The discriminant is the part right here under the root, but you will not take the square root of it. so the square root isn't part of it. So things you need to remember about the discriminant. So if I put in my ABC and my discriminant turns out to be a positive number, okay, if it's positive, then I have two real roots. If it turns out to be 0, I have one real root, and so that's a double root. We'll write it down twice. And if it turns out to be negative, then that means that I have a negative number under a root, which means I have two complex imaginary solutions, or roots. Okay, so this is what you need to know. And we did quite a bit of practice in class with this already. So I've provided some pages here for you to practice. So if you would like to work through these, you can just hit pause, work through, find the discriminant, tell what kind of roots. So when you see something that says describe the nature of the roots, they mean, is it two real roots, is it one real root, are they complex roots? I also provided some examples if you want to pause right here and find the solutions using the quadratic formula. So you will have to get all of these in standard form before you can find any solutions. Okay, there's one more, supporting standards, and then we're going to go into the readiness standards. Compare and translate between algebraic and graphical solutions of quadratic equations. We've also practiced this a lot in class, so I didn't provide any examples. Basically what they're saying here is know that roots are the same, or means the same thing as x-intercepts. That is where I look for the solutions to my equation, and that those are also on our calculators, especially called zeros. So you need to know that those are all the same thing. And that's closely related then to our multiple representations. And again, I didn't provide examples of this because we've done this so much in class. And that is just that if you are given a quadratic function in its equation form, that is your algebraic, that you need to be able to graph that, to build a table with it, and to give verbal description of it. Okay, readiness standard, then analyzing situations involving quadratic functions and formulating equations or inequalities to solve. So I've given an example here. This is going to be an equation, not an inequality, but it'll work the same way. So here's my situation. Farmer is going to build a rectangular garden, and he's going to use the side of a barn. So let's say this is the side of the barn right here as one side. So then he needs the rest of this. So he's got three sides to his garden of fencing. So barn side is one side of the rectangle, and then I have these three sides that are going to be fenced. And we know we have a total of 60 feet of fence. We want to know maximum area. Okay, area is always quadratic, first of all. So we're going to label, so since these two sides are the same, since it's a rectangle, it would be best if I label these as my x, because then I can use x on both. So those are both x long. This side here, I know that I started with 60 feet of fencing, and I have already used up 2x of it. So this side I'm going to call 60 minus 2x. So to find the area, I do length times width. So basically what I'm doing is x times 60 minus 2x, and I'm going to distribute, so I get negative 2x squared plus 60x. So I formulated a quadratic equation to represent this problem situation. Okay, I've gone ahead and see if that comes up for me. I've gone ahead and put this in my calculator. So I graphed this. Here's my negative 2x squared plus 60x. And because it says maximum right here, that means that I am finding the maximum. So I went ahead and I found the maximum. And so my maximum was at 15,450. So the two things I'm working with here are the feet of fence and the area of the garden right here. So then I have to interpret here what's going on. So this is going to be my feet, and this is going to be my area right here of the garden. So I can also tell from this that to maximize the area of this garden, I would want these shorter sides to be 15 feet each, which means that my longer side here would be 30 feet. So the maximum area that he can enclose is 450 square feet. We need to be able to solve quadratic equations and inequalities using many different methods, and we have done this in class, so we'll go briefly through some problems here. So if we have a problem like this, we're going to solve this by graphing. I'm actually not going to go through and solve this for you, but you can do that. What we would do here is, number one, you can put it in standard form and find your x-intercepts, but more simple than that, we can set f1 of x to be everything that's on the left-hand side, so we can graph 2x squared, and then we can set f2 of x to be everything on the right-hand side, which is 7x plus 15, and anytime we graph two things, we're looking for the intersection points. And so we have two solutions here. We can check that on our table. So where the solution is, f1 of x, my y value here, should be the same as this one at the solution. And when I look for a solution, remember, I'm only looking for the x value here. And same here. When I find my points, just the x part of the x-intercepts. Because this is not really a system, we just made it into one. To solve inequalities the way we've done them, to make sure we know what direction our inequality is going, is the same thing here. We would graph side 1, or our left-hand side, negative 2x squared. We will graph our right-hand side, so 12 plus 11x. And find that intersection point, or those intersection points, and then on a number line we will mark those intersection points, and this is an open circle, and then we would use test points on either side of the intersections or intersection, and just substitute back into the original equation. So we take these test points, substitute back in here, and if it's true, then we're going to shade that direction, and then our inequality is going to go in the same direction as our shading will go. Alright, and then this is the big one. Determine reasonable domain and range values of quadratic functions. Interpret and determine reasonableness of solutions to quadratic equations and inequalities. So what we're going to use right here is an equation, and we did this activity in class. So I have already taken my data here and I put it into lists and spreadsheets, and I did a quadratic regression. So quick graph, make sure that you have the right shape that you're working with here. So when I did my regression, I came up with this equation here, so I've gone ahead and graphed and done some work over here. But before we do that, let's talk about our situation. So what's actually happening here is we have his diving board, and he is up on this diving board, and this diving board is already 3 meters up. So when he begins, he is already 3 meters up here. and he is going to come off of that diving board. He's going to hit a maximum point somewhere up there. He's going to hit water level and go down below water level to 5 feet below the water. So he's going to end up 5 feet below. So right in here somewhere is where he hits the water. This is his 0. So we need to find, so this is what I've kind of found over here on our graph. So here's his beginning point, right here at 3. That's where he first jumps into the water. He reaches a maximum height of 4.8 meters. Takes him 0.6 seconds to do so. He hits the water right here after 1.58 seconds, and then he's going to travel on down and hit -5 right down here. And that's really the end of our situation. It's just that part of it. So reasonable domain and range, if I was just looking at this function right here, I would say that the domain is the set of all x's such that x would consist of all of the real numbers, because this is going off the screen, so I have an arrow on the left, I have an arrow on the right. That's all real numbers. My range, I would say that y is everything less than or equal to 4.8, because my graph continues down off the page. But that is not reasonable for my situation, because in my situation time cannot have negative values, so my time has to begin at 0 and it's going to end at 2 seconds, because that's when he hits the bottom of the pool, and so that's when we stop measuring. So my domain, my reasonable domain, is going to be everything from 0 to 2 seconds. My reasonable range is going to be everything from, we start with the lowest number, from the bottom of the pool up to his maximum height, which was 4.8. And these are continuous because we can have parts of time and we can have parts of height measurable as continuous. So that is a reasonable domain and range. The other thing to consider here is reasonable solutions. So we know that when we find solutions, that means x-intercepts. So I actually have 2 solutions here. I have a -0.38 seconds and I have 1.58 seconds for when he hits the water here. But this one isn't reasonable because that's negative time. So we will not use this solution in our situation because it just doesn't make sense. This is the one we would look for if we were asked when he hits the water or what the solution was. And that is basically category 3. Like I said, we have done so many review pages on this already that I think we're in pretty good shape if you'll just go back and look through discriminants and anything else in there that catches your eye. Come in and talk to me and we'll make sure that you're ready on that.